Hello students, welcome to this video that is going to explain your first look at electrical circuits. Okay, so what you see here is the document that I have provided. You have some safety precautions. Always switch off the power supply before modifying circuits. That means you must not be wiring them up while it is still switched on. No way. It has to be turned off. You have to select appropriate voltage ranges on the multimeter, which I will show you. Do not short circuit the power source except at the beginning. Again, I'll show you that. Yeah. So here's part one. This is where you will just read the value from the board, and it's going to say 10 ohms, so you'll enter the 10 ohms there. The second one, the labeled value is 33 ohms, so you will enter 33. You don't have to enter ohms because it's already shown here. And then the third one that you're looking at is 100 ohms. And then you have to use the multimeter to measure them, and you will put the measured values here. Now the error is going to be, so let's assume that this is, you're going to measure this as 10.5. Just giving an example. If that's the case, then the percentage error would be the measured value minus the labeled value and divide them with the measured value, right? So divide them with the, no, actually with the theoretical value. You will get that as a number, and this is going to be what, 0.5 by 10, that's 0.05. And then after that, you have to multiply it with 100 because you want it as a percentage. See that? So that will give you 5%. So I'm just showing you how to calculate the error. So you do this part. Once you get that number, multiply that with 100 because you want it as a percentage. Okay, in the second part, you are connecting them in series and in parallel. And what you do is here, you enter the measured values. So I'm just making up the numbers. So if this is like 33.3 and 10.5, you just copy that here. You go, oh, this was 10.5 and this was 33.3. See that? And then of course the calculated value in series would be the sum of them. So that would be 43.8, right? Yeah, 43.8 ohms. Then this is the part which you have to measure. Again, you calculate the percentage error just like before. Do the same after you connect them in parallel, but here you're using the same resistors. You're putting those same ones in parallel, so fill that up, and then you calculate this. Now, in order to calculate this, you have to use the formula 1 over R is equal to 1 over R1 plus 1 over R2. Let me do that quickly, and you're going to get 33.3. Okay. Divide by so that's going to give you 7.98, all right? And then you have to measure that and find the percentage error. So it's only the measuring part that you have to really fill up, okay? There. Even here, you're just doing the measuring part. Now go to part 3. This is the interesting part where you're connecting two resistors in series with a battery and a multimeter. So here is the battery or the power source. Here's the multimeter, and here are the two resistors, 10 ohms and 33 ohms. Just look at this, there are only 3 cables here, okay? Cable 1 to the negative of the power supply, that will be the blue one. And then from the positive of the power supply, you connect it to where it says milliampere on the multimeter. And from the common terminal, you go to the bottom of this. Now all of this is going to make sense when I show you the actual circuit. So let's go there right now. All right, students, what we have here today is trying to have a first look at electrical circuits. So I have a circuit board with me that I'm going to explain first. This is what we're going to use for the lab. Now, as you can see, there are 3 resistances, 10 ohms, 33 ohms, and 100 ohms. Those are the 3 resistances we're going to use in the lab. Now you have other resistors here, you have a light bulb, and you have 2 capacitors. We'll get to those later on. For now, do also check and notice that each resistor has 2 ends, right? Each one has 2 ends, and one of their ends is connected together, as you can see. So one end of each resistor is connected together here. So that means if you take a cable from here, that would be the point where all 3 resistors are together. But at the other end, they are not connected together, they are independent. So that's what you got to first understand. Now, to measure each resistance, what we do is we need a multimeter, and because we're going to measure resistance, we need to put it on the resistance, which is, you can see the resistance part here. So let's put it on 200 ohms. So I have it on 200 ohms now, right now. As you can see, 200 ohms. And whenever you connect the multimeter, no matter what you're measuring, the black goes into the common. So the black goes into the common because it's the negative. And if you are measuring resistance, then if you look carefully, let me also use the phone and try to zoom in a little bit more so that makes more sense. Now you're trying to measure the resistance, so that's why it's on 200 ohms, as you can see. And the next cable should be on this, because you see that it says temperature, ohm, voltage. So if you're measuring any 3 of those, that's where you put the next cable. So that's what I did now. So I have 2 cables ready to go on the multimeter. In order to measure the resistance, remember there's nothing connected on the circuit board. All you got to do is take the black cable from the multimeter and connect it to the 10 ohms, as you can see now. And the red one, so that's from the red one from the multimeter goes to this. And as soon as you look at it, you see that the multimeter reads 12.4 ohms. So that's the measured resistance. Well, 12.3. The labeled resistance is 10 ohms, but the measured resistance is 12.3. Okay. Now you got to measure the next one, which is 33, right? The labeled is 33. All we got to do is take off the cable from there, put it on this, because now you hooked it to the 2 ends of 33. See that? And let's see how much it reads. Oh, it reads 36 ohms. That's how you measure individual resistances. Good? I hope that makes sense. Now to measure the third resistance, I think it's easy to understand that you just move this and it's supposed to read 100 ohms, but it reads 101.9. So that's the measure. All right, after measuring all the three resistances, now what we got to do is we got to connect the first two resistances in series. The 10 ohms and the 33 ohms in series, all right? How are we going to do that? So turn off the multimeter, remove the cables from the multimeter, and then look at the circuit again. In series, you want the current to flow through each one individually. So that means you want the current to go from this, maybe through this resistance, it goes into the other one and comes out. That's what you mean by series. So in a series circuit, two ends of those are connected together, but the other two ends must be free. So here, these two resistances are already connected in series. And to measure their total resistance in series, we need to know where to put this. Okay, let me turn on the multimeter again, put it on 200 ohms, and then you need to be careful where you plug this in. Okay, so you put one there and the other here, and you get the total resistance in series, 43.8. Remember, it's supposed to be 43, like in series, you add the resistances. So since you have 10 ohms and 33 ohms, when you add them, you get 43 according to the label, but the actual one is 43.8. Is that clear enough? All right, in the next part, we need to connect these resistors in parallel. Okay, turn off the multimeter, which is what I'm doing now. Turn it off. Remove the cable. Remove the multimeter. I removed it off, but it's ready to measure, but it's taken out. Let's take another look at this. In a parallel circuit, both of the ends of the resistors must be together. So we already have these two ends together, but these two ends are not together, are they? No. So we need to use a cable and put them together, which I did now. See that? Now I have put these two together. This is a parallel combination. Now to measure it, once again, I'm going to put this on the 200 ohms because I'm measuring resistance. And then you have to be careful. This time you take one from here, okay, and the next of the multimeter, you hook it here. All right. So don't hook them up at these 2 points. Don't. You can use either one of these. That'll be one. I use this. And the other one should be taken from here. When you do that, you get your resistance in parallel. How much is it showing? 7.8 ohms. Do remember that in parallel, the resistance is going to become smaller than the smaller one. So we got 10 ohms and 33. The smaller one is 10. And quiet, right? This is smaller than 10. Now you got to calculate the resistances in parallel using the formula 1 over R is 1 over R1 plus 1 over R2, and check the error. Okay. Now we come to the last part. In the last part, we are going to measure current. For the power source, you turn it on Okay, it's off now. Turn it on, and without any cable, adjust the top, because it says output voltage. Adjust that to change the voltage and make it like 2 volt or 2.1, 2.2, which I've done. You see that the current reads 0 now. To change the current, you will have to use a cable to connect the negative to the positive. So I'm using a single cable, as you can see, and use a single cable to connect the negative and the positive together. And then you see that the current is showing a reading. And turn the lower one, because it says current, output current, get it as close to 0.5 as possible. Need not be exact, but okay. So that's the current that's being produced. All right, it's fluctuating because the AC voltage is fluctuating. That's okay. Now you can switch off. It will store the voltage and current in its memory, so it doesn't go off unless you unplug it. Don't unplug it. And then we are going to connect the two resistances in series. Let me show you how to do that. We already know. Okay, but since we need to measure the current, we need to be careful now. And we have to have the multimeter also come in. You need the power supply, you need the multimeter. So let me start from one part. We need 3 cables. That's all we need, 3 cables. You take one cable from the positive, use the red cable, from the positive, okay, and hook it to the 10 ohms, the bottom of the 10 ohms. So that's cable number 1. All right. So you can already see that the current has a path from the positive through this cable. It reaches here, and then it'll go through this 10 ohm and it'll come here, but there is no way to complete the circuit. So what we're going to do is we'll take a second cable and we will connect the negative of the, let me remove this. See the common, which is the negative? That we will connect to this. All right, let's see if you can see it. Okay. So now the current has a path to flow through this cable, through the meter, and it reaches here. But then it has nowhere to go, so we'll take the next cable, put it on the milliampere, see, remember, milliampere, and hook it back to the negative. You were supposed to use a black cable, but I'm just going to excuse myself working with one hand, because for negative use a black. Okay, so there, those are the 3 cables. Again, let's look at the path. So you have one cable from the positive going to this 10 ohms, right? So the current will go through the 10 ohms into this 33 ohms. Since you have the black cable there, the current will go through the black cable into the common. Okay, you see that? Into this common. Through the meter, it'll go to this cable, and then you have this red, and all the way back to the negative, and through the battery, the circuit is completed. So the only thing you have to do now is be careful, since you're trying to measure current, make sure you put it on direct current, or direct current, the way you want to say it. Okay, so the direct current is out here. You can see 20 ampere, 200 milliampere. So we've got to put it on 200 milliampere. So that's what I'm doing now, 200 milliampere. Okay, right. And then it's reading 0 because it's not turned on. And do not turn it on until you have everything set up. Now turn it on. When you turn it on, it's going to give you the current, 48.9 milliampere or 49.0 milliampere. It's going to fluctuate a little bit. Write that down, and then you calculate the current and check if this is close to the calculated current. That is your lab. It has three parts. Once again, first you're measuring the resistance, all three, and then you're hooking them up in series and in parallel, getting the total resistances, and then finally you are putting up the battery through it, sending a current, and you're measuring the current. Thank you. I hope this makes sense.